Understanding sklearn, dummy a detailed exploration. The sklearn, dummy module in scikit-learn provides a set of baseline or dummy estimators. These estimators are used for comparison purposes and benchmarking in machine learning. They don't actually learn anything from the data, but instead, they employ simple, predefined strategies to predict outcomes. Key points. 1. Baseline performance. The main reason for using dummy estimators is to establish a baseline performance for your machine learning model. This baseline allows you to assess whether your chosen model is actually improving upon a simple non-learning approach. If your model performs significantly worse than a dummy estimator, it might indicate issues with your model selection, feature engineering, or data preparation. 2. No learning. Dummy estimators do not learn any patterns from the data. They are not trained in the traditional sense. Instead, they rely on predefined rules or strategies for prediction. 3. Different strategies. sklearn, dummy offers several different strategies for generating predictions. Stratified. This strategy is used for classification problems. It predicts the most frequent class in the training data. This is particularly useful for evaluating imbalanced datasets where a simple majority class prediction might be misleading. Most frequent. Similar to stratified, this strategy predicts the most frequent class across the entire dataset, regardless of the specific training data. Prior. This strategy predicts based on the prior probabilities of each class in the training data. This means it will predict the class that is most likely based on the observed class distribution. Constant. This strategy predicts a constant value, which can be either a specific class label or a numerical value. This is useful for comparing against models that predict a fixed value, such as always predicting the average. Uniform. This strategy predicts randomly from the possible values. It is helpful for comparing against models that might be overfitting or making random predictions. 4. Evaluation metrics. It's important to note that dummy estimators are not intended for making predictions in real-world scenarios. They are only useful for evaluation purposes. You can use standard evaluation metrics like accuracy, precision, recall, F1 score, or mean squared error (MSE) to assess the performance of your dummy estimator and compare it to your actual model. 5. Example usage. Python. From sklearn, dummy import dummy classifier. From sklearn, datasets import load iris. From sklearn, model selection import train test split. From sklearn, metrics import accuracy score. Load iris dataset. Iris load iris. X iris. Data. Y iris. Target. Split into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Create a dummy classifier that predicts the most frequent class. Dummy CLF. Dummy classifier strategy. Most frequent. Dummy CLF. Fit X train. Y train. Predict on the test set. YPRED. Dummy CLF. Predict X test. Calculate accuracy. Accuracy score test. YPRED. Print dummy classifier accuracy. Accuracy. This code demonstrates creating a dummy classifier that uses the most frequent strategy, fitting it to the training data, and evaluating its performance on the test set using accuracy. In conclusion, sklearn, dummy provides a simple but valuable tool for establishing baseline performance in machine learning. It allows you to compare your model's performance against a non-learning approach, providing insights into its effectiveness and identifying areas for improvement. While dummy estimators are not meant for real-world prediction, They play a crucial role in model evaluation and understanding the limitations of your chosen approach.